Hello everyone, hope all you are doing great. Today we will study about basics of automation, that will give you the idea of different types of automatic process. Let us start with the introduction to automation. There are basically three types of process control. First, digital process control, in which we can control the output for on or off conditions. Second, analog process control, in which we can control the output for 0 to 100% whole range. Third, motion control, in which we can use the servo drives, in CNC, 2-axis, 3-axis, 6-axis robotics control machines. These process control can be controlled by open and closed loop systems. Open loop system is a manual control system, in which we can control the output directly by pressing start or stop push buttons, selector switches etc. for digital process control, and using temperature, level sensors etc. for analog process control. Moving to the closed loop system, basically there are four types of systems, that is. First, pneumatic control, in which logics are operated by air pressure, which is then given to the pneumatic cylinders to make or break the electrical circuit. Second, relay ladder logic, in which electrically operated relays are used to make or break the circuits, and ladder name indicates that the logic will take the form of ladder-like steps. It is designed as per electrical IEC standard. Third, electronic control, in which logics are made on printed circuit board and using a semiconductor device, which are also called as solid-state devices. Fourth, programmable logic control. It is an industrial computer which also has a central processing unit like in personal computers, but the difference is, of input and output devices, which are industrial sensors and actuators. The main thing is the programming language we are going to use, is same as relay ladder logic, and most important thing is we can reprogram it in the computer software. So, the summary points are: 1. Electrical control is a compact version of mechanical control. 2. Electronic control is a compact version of electrical control. Let's take an example of digital process control, that is, room light and door control application in which we need to control the outputs of light and door. This has to be done by automatic control action with the help of electrical or electronic sensors which would be used to give the physical feedback of presence and absence of any object in the room. In this example, we have a digital proximity sensor, which can sense the presence or absence of the person in its proximity range, and sends the electrical signal to its control system, which may be the relay ladder logic, electronic control, or programmable logic control. The signal can be AC or DC voltage as per our need. In this case, we consider DC voltage signal which is to be 24 volt DC. So, when the person presence detected in the room, it will send the 24 volt DC signal to the control logic, and no signal when absence is detected. After that, these signals are executed in the logic and sends the controlling signal to the actuator device. In this case actuator device is relay or the contactor switch, and again signal is 24 volt DC or 0 volt DC to turn the light on and off. We can also control the output by giving a delay, to turn the light on and off. For this we would use the electronic timer circuit, to provide the delay. Now moving to the door control example, if we want to control the door and make it lock for limited number of persons, then we need to count the number of persons entering in the room. For this part we need a counter to do it. Now let's look about analog process control. Consider an example of room temperature control. To measure the room temperature, we have a RTD-PT100 temperature sensor having a range of 0 to 120 degrees C. But this physical property of signal could not be sensed by controller directly. So, sensor signal is calibrated to electrical voltage or current DC signals, that is, 0 to 10 volts or 4 to 20 milliamperes. We can see in the table given below, the whole range is divided into percentage format. At 0%, temperature is 0 degrees C, voltage signal is 0 volts. At 25%, temperature is 30 degrees C, voltage signal is 2.5 volts. At 50%, temperature is 60 degrees C, voltage signal is 5 volts. At 75%, temperature is 90 degrees C, voltage signal is 7.5 volts. At 100%, temperature is 120 degrees C, voltage signal is 10 volts. So, if we have a set point of 20 degrees C, process variable of 30 degrees C which is sensed by RTD sensor, that means sensor sending the signal 2.5 volts DC to the controller as given in the table. Then calculated error is minus 10 degrees C, so to overcome this error controller should turn on cooling element. The cooling element would be a throttling flow control valve to control the cooling fluid. Thereby controller output should be an electrical control signal, that is, 0 to 10 volts DC, 4 to 20 milliamperes DC signal. These are the standard control range signals. For this type of process, controller should be a PID controller is known as proportional integral derivative control. Like this we can control other variables example water level, pressure, flow, speed etc. There are more things to do in automation. This is it for this session. Thanks. If you like this video do not forget to like and share.